Hello, students. Welcome back to Lesson 8. We're going to be talking about inequalities, and we're going to be doing two types of inequalities. The first type of inequalities we're going to be dealing with is going to involve just one variable. Okay, so that's where we'll just have an x, and we'll talk about how to represent what's happening in situations where there's only one variable. But then we're also going to learn how to graph linear inequalities and systems of linear inequalities, and that'll have two variables in it. Okay, so the first couple things here are really just working with one variable, and the last one will work with two variables. And I want to warn you that for the ones with two variables, I'm not going to be covering how to graph in terms of how to graph the straight lines we're going to be dealing with. Instead, we're going to use Desmos, a graphing calculator, to graph the lines for us. And we're just going to be understanding what it means to be less than or greater than a line. Because in the future lessons following this one, we're actually going to learn how to graph all these individual things. And so when we get to that, then we'll learn how to graph all those lines in detail. All right, let's go ahead and get started by reading our application. This is a tough one, by the way. A dietitian is planning a snack package of fruit and nuts. Each ounce of fruit will supply 1 unit of protein, 2 units of carbohydrates, and 1 unit of fat. Each ounce of nuts will supply 1 unit of protein, 1 unit of carbohydrates, and 1 unit of fat. Every package must provide at least 7 units of protein, at least 10 units of carbohydrates, and no more than 9 units of fat. Let X represent ounces of fruit and Y represent ounces of nuts to be used in each package. Graph the feasible region described. So as of right now, that might sound like a whole bunch of nonsense, but believe it or not, it's actually a fairly easy problem once you know what you're doing. And this is a skill called linear programming, where we are not going to actually learn linear programming in this class, but what we will learn in this lesson is how to find a feasible region, which all a feasible region means is what are the possible answers to this question? So we just described a complicated situation involving having ounces of fruit and nuts in a snack pack, and we'll find out how many ounces of each make it possible to meet the requirements of protein, carbohydrates, and fat that were described. Because there might be more than one possible answer, so that's why we get a whole region, not just one specific point. But we will come back to this one at the end. Once we know how to graph linear equations, then the only trouble with this problem is the setup, writing those equations down. But I'll show you how to do that when we get back around to this. All right, so set builder notation and interval notation. These are the two ways that we generally describe sets. So we might describe a set in words, which is what's happening over here on the left. But mathematically speaking, usually we either use set builder notation or interval notation. And most of the time, we'll want interval notation in this class. There is really no good reason to choose one over the other between set builder and interval notation, other than in some situations, one is more convenient than the other one is. So most of the time, interval notation will be the more convenient one, but occasionally set builder notation will work out to be easier. So it really just depends on the situation. There's just a couple of things I have highlighted here that I want us to talk about before we dive into the lesson. So up here at the top in yellow, if we want to describe all real numbers between A and B, but not including A or B, we could do that in set builder notation by saying, how you would say this one right here out loud is the set of all X such that A is less than X, which is less than B. Or you could say it as the set of all X such that X is between A and B. Where notice that this symbol and this symbol do not have the little bar underneath that means or equal to. These are just strictly less than symbols, because that's how we're going to indicate that we are not including those endpoints. Okay, as opposed to this one down here is a greater than or equal to symbol. Notice that little line underneath tells us to include A. Okay, so up here, no equal signs underneath. So we are not including A or B. We would represent this as, in interval notation, you write the smallest value on the left and the biggest value on the right. And because we are not including A or B, we use a parenthesis on both sides. If instead we look at the second one here, all real numbers greater than a, but not including a. Okay, all real numbers greater than a means we have no cap. We can go all the way up to infinity. So in our interval over here, notice the right side, instead of being a b value, is an infinity symbol because we go all the way up for forever. And we still have parentheses on both sides because we have a greater than symbol with no equal sign. So this left symbol here on the A is a parenthesis because there's no or equal to part on that greater than. And then a parenthesis is always going to go on the infinity. So whenever you have infinity like this, you always put a parenthesis. And that's to indicate that infinity really isn't a number, it's an idea. Okay, it's a concept that represents us going infinitely far in that direction. And so you can't really include a concept, right? It just keeps going because there's always another number past infinity. You know, you can find infinity plus 1, and that's just a new infinity. So we always use a parenthesis whenever it's infinity because it's not technically included. All right, to see the opposite of what it looks like when you do include something, if we have all real numbers greater than a, including a, then we're going to do the exact same thing, but now we have a greater than or equal to symbol, and we will use a bracket on the a. So if we want to include something, we use a bracket and this or equal to part on the inequality symbol. If we don't want to include it, we use a parenthesis and no or equal to part on that symbol. All right, and then all the others are just variations of this. Feel free to read through that chart, but it's just different variations. So let's go ahead and describe some sets. So number 1 here says to graph the described inequality and write an interval and set builder notation. So first, to graph, this means to represent it on a number line. And so that's why I have 4 horizontal lines here. Those are my number lines. So first thing we're going to do is graph number 1. It says Sarita can own up to 10 fish. So I'm going to put the number 10 on here because that's the only number we have described. And if you can own up to 10 fish, that means 10 is an option. Okay, up to 10 includes 10. So on a graph, the way you include something is you put a closed dot. Okay, the other option would be to put an open dot. So see that open dot next to it where the inside is still white. But a closed dot means we include 10. Now, this is a little controversial, but when it says you can own up to 10 fish, technically that means there is no lower limit. So I'm going to draw an arrow going to the left. If you want to make a real life argument, you could say that this should stop at 0 and be 0 to 10 because you can't have negative fish. I completely understand if that's how you feel, and you can put that answer instead. But technically, the way it's described, Sarita can own up to 10 fish means she can own any number less than 10. So again, it's reasonable if you stop at 0, but I'm going to let this one go all the way down to a negative infinity. And so in set builder notation, the way we can represent this is the set of all x. Okay, so that squiggly brace there represents it being a set. And what's in the set? Well, it's all numbers x such that is this vertical line. And then we can have anything less than or equal to 10. So x is less than or equal to 10, and I put another brace on the other side. So again, this first part here is the set of all x. This middle line stands for such that, meaning we're going to have a restriction on the set of all x. And the right side is the restriction. So this is the restriction that x needs to be less than or equal to 10. Okay, so very, very just formulaic process. We say what's in the set, and that's everything that's an x, but then we give a restriction on it. X has to be less than or equal to 10. All right, and then as an interval, all we do is we take this and we write it to be smallest number all the way up to biggest number. So in this case, sorry, I got a little cavalier with my parentheses there. In this case, we're going from negative infinity all the way up to 10, where we use a parenthesis on negative infinity because we always put parentheses on both positive and negative infinity because they're never included. But we're going to put a bracket on 10. Okay, so over here we have a bracket because that bracket represents that 10 is included. All right, now part B. Brian must work at least 10 hours. So if he must work at least 10, that means he can work 10 or he can work more than 10. So we're going to take the exact same thing but have it go the other way. So this is the set of all x such that x is greater than or equal to 10. And so instead of negative infinity to 10, now we're starting at 10 with the bracket and then going all the way up to positive infinity. Okay, where again 10 is included because if Brian must work at least 10, that means 10 is a possibility. 10 is at least 10. Okay, part C, Sylvia wants to have between 6 and 10 friends inclusively. Inclusively means to include the endpoints. So we're going to put 6 and 10 on here. And we're going to put closed dots on 6 and 10 because we will include those 2 points. Okay, so inclusively means to include the ends. So this is the set of all x such that 6 is less than or equal to x is less than or equal to 10, where we have or equal to's on both inequality symbols to indicate that we are including both 6 and 10, which also means we will use a bracket on the 6 and the 10 in interval notation, where again in interval notation you always go smallest on the left, biggest on the right. Okay, part D, Catherine has somewhere between $5,000 and $5,000 exclusively. Exclusive means to exclude the endpoints. So I'm going to put 5 and 5,000 on my number line, but I'm going to put open dots. Okay, see the open dots right here. Open dots to represent that those are not included. So in set builder notation, I'm going to say x needs to be between 5 and 5,000. But this time I'm going to put strictly less than symbols. Okay, so there is no or equal to's on these because those endpoints are not included. And then in interval notation, not including means I will use parentheses on both sides, the 5 and the 5,000. All right, some more practice. We're going to do this from a little bit of a different angle now. We're going to express the following sets using interval notation. That we've already been seeing. But now we're going to have to describe the situation that this might relate to. So we'll do the easy part first, which is interval notation. X less than or equal to 1 means x can go anywhere from negative infinity all the way up to 1, where we include the 1 with a bracket because less than or equal to means 1 is included. And then as a potential reason of what could happen here, well, we got to think what could be negative. And whenever I think negative, for whatever reason, my mind always goes to money. Or you might think you can't have negative money, but well, what if you go into debt, right? You can have infinitely much, as much debt as you want, really. So I'm going to say that this represents a company's profits are being less than or equal to $1, meaning they may be super negative or they may be all the way up to $1. So a company's profits are less than or equal to $1, which is a fancy way. Like if someone has a business and they're like, hey, my profits are less than or equal to $1, that probably means they're not doing so hot. Okay, that probably means they're in the debt because they're probably trying to say, hey, they're negative, but I'm going to describe it generously by saying less than or equal to $1. Okay, part B, -5 is less than x is less than or equal to 9 as an interval, parenthesis, -5 to 9 with a bracket. And then a real life situation, here, when I see -5 to 9, I think about like a cold day in Minnesota. Okay, so my real life situation is going to be that the temperature is greater than -5, but less than or equal to 9. Lots of words here. And, oh my gosh, lots of words and I wrote them wrong. So the temperature is, it should just say greater than 5, no or equal to part here. So I got to take away the or equal to because we're not including 5. So it's not or equal to 5. Let me go ahead and get rid of that. Get rid of the word to also. So the temperature is greater than 5, but less than or equal to 9 degrees. So less than or equal to 9. All right, and again, I think cold day in Minnesota, okay? And I didn't even write the negative sign. Oh my gosh. All right, couple errors here, but I got it right now. So the temperature is greater than -5, but less than or equal to +9. Sorry about the mistakes there, team. All right, part C. -2 is less than or equal to x is less than 4. As an interval, we would include the -2, so a bracket on -2, but not include the 4, so a parenthesis on 4. And when I see this one, I had a little bit of trouble coming up with something too accurate. But what I was thinking is it's tax season right now, okay? At the time of me recording this, right now we're in early March. So I was thinking my tax return will be less than $4, but I'm not going to have to pay more than $2. Okay, and what I mean by I won't have to pay more than 2, well, if you have to pay, that's like a negative tax return, right? You're losing money. And so to me, that sums up this situation. And maybe instead of dollars, maybe we're talking about thousands here. But either way, I'll just leave it as dollars. So my tax return will be less than, and strictly less than, no or equal to, $4, but I won't have to pay more than $2, which means I might have to pay $2. That would represent -2, but I won't have to pay anything more than -2, which means this value won't be less than -2. Okay, so that'll give me the range -2 to 4. All right, and then part D, we're going from 1 with an open circle, so that's a parenthesis at 1, to 3 with a closed circle, so that's a bracket at 3. And so for this one, I just thought of my household, which is I have more than 1 pet, but less than or equal to 3 pets. So I have more than 1 pet. My first pet was my dog, Robin, but less than or equal to 3 pets. And my roommate has 2 cats. So in total, we do in fact have 3 pets, but really I just have the one, which is Robin. So I have more than 1 pet, but less than or equal to 3. I consider it having like 1.5 because I have my dog, Robin, and then there's 2 other cats around. All right, moving on. We are going to solve one variable inequalities now. So to solve inequalities, we isolate the variable just like we would with an equation, but there's one exception, and that exception is that if we multiply or divide both sides of an inequality by a negative, we must reverse the inequality symbol. Okay, notice multiply or divide by a negative, reverse the inequality symbol. Okay, that's the only difference between solving inequalities and solving regular equations though. So for part 3 here, I start the same way that I would solve an equation, which is drawing this vertical line to keep me organized. I have x minus 16, so I'll do the opposite. I will add 16 to both sides. That will simplify to give me x. The 16s go away, and then positive 8 on the other side. And because I didn't do anything to the sign, it still faces the same way. So x is greater than 8. All right, and then when it says to graph, that's just the number line again. So if we represent these solutions on a number line, I would put an 8, put an open dot because no or equal to sign, and greater than means we're going off to the right. All right, number 4, same idea. I'm going to start by drawing a vertical line to keep me organized. I see negative x plus 2, so I'm going to subtract 2 from both sides. The 2's on the left will cancel, so I have negative x is less than or equal to, and 7 minus 2 is 5. So now I have to get rid of that negative x. So the way you do that is you divide or multiply by a negative 1 on both sides. But the new rule for inequalities is that if you multiply or divide by a negative number, you flip the sign. So I get x on the left and negative 5 on the right. but I can't leave that symbol facing the same way. Instead, I have to flip it, so now it's a greater than or equal to. So my answer is x is greater than or equal to -5. And so on a number line, I would put -5 on here. Greater than or equal to means a closed dot at -5 with an arrow going off to the right. All right, number 5. By the way, if you haven't paused the video and tried a couple yet, now would be a fantastic time. All right, that was me pausing and waiting. Okay, so now vertical line through the equal sign. We have 4x equals -12. In order to get the x by itself, I'm going to multiply both sides of this by the reciprocal of 4, which is 1/4. And when I do that, I'm going to get x on the left and then -3 on the right, because -12 divided by 4. Now, you might think that the 12 was negative, so I just multiply or divided by a negative, but not the case. Okay, this 1/4 that I wrote down was a positive 1/4. So even though there was a negative in the problem, I did not multiply by a negative, I multiplied by a positive 1/4. So the inequality symbol is going to stay exactly the same, still a less than. So my answer is x is less than -3, which means I can throw a -3 on a number line, put an open dot, and having it go off to the left. Okay, number 6. We're going to draw a vertical line under the inequality symbol. -3y plus 2 is greater than -7. I'm going to subtract 2 from both sides. When I am subtracting, I don't do anything to that inequality symbol. It stays put. It's only if you multiply or divide. The 2's cancel. I have 3y, -3y, is greater than -9. And now, because I'm going to multiply by a -1/3 on both sides, the fact that this 1/3 is negative means I switch this inequality symbol. So in my next line, I'm going to get y by itself on the left and +3 by itself on the right. But I have to flip this inequality symbol right here to go the other direction because I multiplied by a negative. So I get y is less than 3. Okay, when you flip that sign, we end up with a less than. So I'll put 3 on here. Open dot because there's no or equal to part, and less than means we go off to the left. All right, and that is the end of solving one variable inequalities. So now I'm going to go ahead and cut this video off. In the second part of the video, we're going to learn how to graph linear inequalities, which are going to have 2 variables in them. But again, I'll save that one for the next one. If you made it this far, you're on the right track, you're doing great, and I hope you enjoyed this.